Hello, stars. I'm Chris Baird, and I also center star. And this is Hollow Earth Continued. And today we're going to be covering a lot more about what I didn't go over in the journey of Olaf Jansen. I know you guys are anxious to find out what happened with Olaf Jansen after he reached the inside of Earth, and we will be going over that, but we have to backtrack a little bit. First thing I want you to know is that there's polar vortex over each pole, okay? And what that is atmosphere from inside of the Earth, warm, moist atmosphere coming out, and then creating cloud cover once it hits the colder atmosphere, and those clouds drift off. And they also cause the vortex, which drives our winds from west to east, okay? It's milder in the summer, it's a little bit more found as it spins up and slows down in the winter. So he was going north with a strong breeze pushing him, which I'll go over in a little bit here. And he came into iceberg fields. They had a bad storm. They were lucky to survive. And when they got to this point, it was very calm. And they had these huge icebergs that were like clear crystal and beautiful rainbows emitting from them, giving off a light around this opening ahead of them. And then once they were inside of it, they could see what was causing that was this apparition sun. The other sun had disappeared behind them. And that has to do with the angle of the center star in relation to the outer sun, which I'll go over in a little bit. He described the inside of the Earth as having no clouds except for around the center star, where it had a hazy appearance from the steam given off at the center star. The inner temperature was around 75 degrees Fahrenheit. That's 23.889 degrees Celsius. Pretty much all the year except for some fluctuations at the poles, some variances, a couple degrees either way. And what cools that is caves, polar openings, and side openings on the Earth. And as you can see, we also have the Aurora Borealis and the Aurora Australis, and that is a secondary vortex that goes down to the poles of the center star, which is metal, and aligns it into a powerful magnet where it gives heat off everywhere else, okay, on all the other surfaces. All right? Okay, so like I said, I was going to go over this. The angle of the sun inside of the Earth or center star is proportionate to the exterior sun and the tilt of the Earth. So as the Earth started tilting this way to start a South Pole summer and the Earth was going into winter, they were traveling in September, October, so this had started to happen. And so the slag material on the metal on the inside coagulates, in my hypothesis, towards the outer sun. And so you can see the daylight angle was peeking out, okay? And I drew this is the magnetic poles, sorry about the light there, magnetic poles over here, but actually it would be in line with this. I just didn't want to disrupt this day and night. This is day, or this is night and this is day, and this is night and this is day. It's opposite inside the Earth. So anyways, okay, so what you need to know about this actually goes right here, and it's in the Baffin Bay areas where our actual magnetic poles are, and somewhere in the south away from the actual rotational axis of the Earth, okay? And what's important about that is if you're in Colorado and you're looking at a compass, 10 degrees to the right is your magnetic north, and if you look 10 degrees to the left of that, that's your true north. And if you're on the East Coast, it's a lot closer in proximity, only about 3 or 4 degrees, because the whole of Baffin Bay is almost directly above the East Coast. So magnetic north is directly due right above them instead of off to the side. And then they have to, go just a little bit left of that to be going true north. Not much, okay? So, with that, I'm trying to go over everything here. Okay, so he was being pushed in by strong northerly winds, all right? He traveled up by Franz Josef Land, which is modern-day Iceland, and went up north that way. And he was being driven by strong northerly winds, and so that's why they were able to make it in with regardless of the compass, because they were going through fissures in the ice, and with the wind behind them, they could only go one direction. And they were very lucky to make it in and make it through all the icebergs without having their ship capsized. They nearly did have that happen. What happens here is during this tilt, okay, at times of the year, we actually have air intaking at one pole and expelling at the other, and the opposite at other times of the year. And we can get Hypotheticals all the way down. And if you look at the last, I think it's the last video's, what do you call that? Screenshot or whatever, the thumbnail. I have an example of a transcontinental pole-to-pole Hypothetical. And Hypotheticals are, again, the hollow earth opening air exchange vortex tubes. But at this time of the year, in September, October, we start getting the openings at the side actually venting out steamy, warm, moist air from inside the earth, causing storms over here by the Bermuda Triangle opening, and another opening over by Africa. And these storms build up and they spin off and they start hitting across the ocean towards the United States and South America. They hit land and they dissipate over and over again during this transition as the crust is tilting. And so the air is expelling here and then being drawn again in the North Pole hole. Okay, so that's the wind that was driving them forward. And if you look, a lot of these openings are deadly given away by the Hypotheticals in the air. Okay, you may not be able to see the opening in the water because it's cloud covered, but you will see the Hypotheticals, these tubes bouncing off to different points on the earth with vortexes that you think are storms, and some of them may be. And then there's also the Hypotheticals that just go out and touch the outer atmosphere, or go out and create a side storm. And it's just to do with if it's intaking warm air or if it's expelling warm air and bringing in cool from a different area. It all depends. So what happens to people in the Bermuda Triangle? Well, when Olaf was going through here, the magnetic disturbances between this opening and the Baffin Bay one were causing his compass to go crazy, okay, bouncing back and forth. And as he went inside, it turned north again. And that's another thing you need to know. If you're traveling north and then you go into the planet, you're traveling north all the way down to the south again and then back north this way. If you're going south on the outside, you're going south all the way in and around, because that's where the poles are. All right, on the center star inside the Earth. I know that's upside down thinking, but all of this is. But once you understand it, it's easier to understand. So what's happening here is there's a down force of gravity at the curvature, just like this, in all these directions on these openings. And planes are flying along and they hit this mist from all this moisture coming out. They can't see visually, so they have to rely on their gauges. And their gauges are bouncing back and forth between the North Pole and the Side Pole, both reading north and doing this number back and forth, trying to decide which way is north. And if they're flying east, they think north is far off to their left, but their compass is reading between that, bouncing back and forth or even going further. Okay? But what happens too is elevation-wise, they may be flying at 1,500 feet on their altimeter, and suddenly, just out of nowhere, the clouds open up and they're 50 feet from the ocean and they crash. And there's a lot of mad currents in here that will sink boats, mini whirlpools outside of the water whirlpool going around. And so this is why a lot of planes disappear, is because their compasses and their equipment is going crazy compared to what they know anywhere else where the crust is solid all the way through. So we covered weather, we covered the ice sheets, we covered the temperature inside Earth, we covered the auroras, we covered the poles and caves. And again, that's called the Bifrost here. And the Bifrost, again, is that rainbow of light that the Vikings talked about. So I think we covered almost everything except for one thing. That's why I was going over this, make sure I didn't miss it. This is my 5th attempt doing this. The Atlantic side of Earth is closer to the center star than the Pacific, which is bulging. What you need to know about that is as the Earth started to expand outward, the Atlantic was struck and it started expanding like this and creating our new ocean floor in the Atlantic, and all the water was falling off into that. And we started getting land, and dinosaurs started to exist on the surface of Earth. And then it was hit on the Pacific, and it killed off the dinosaurs, and it also bulged out and it started to expand even faster on the Pacific side, which is squeezing the Atlantic and causing the mountain ranges to pop up. And so that explains a lot, and that's backed up by age of ocean floors. The Atlantic ocean floor carbon dating is estimated to be about 145 million years old, give or take, or older than that. But on the Pacific, they found readings as young as 65 to 75 million years ago, which is in line with when the dinosaurs were killed. And yet, the Pacific side, the Pacific plate, is much larger in comparison to the Atlantic. So that goes over everything for this video, and we're going to continue on with this and Olaf's journey inside of the Earth in the next video. So thank you for tuning in, and again, if you guys could subscribe and hit the bell notification icon, I'd appreciate that. If you feel like sharing this, that would be wonderful. And peace. Look forward to talking to you guys next time.